We're going to continue example 4 in topic 2.5 and 2.6. So in this next one here, we do need to take these denominators and move them up by making the exponents negative. So we have f of x equals 2x to the negative fourth plus 4x to the negative 2 minus 4. Now we're ready to take the derivative. So f prime of x equals, I'm going to take this negative exponent and move it in the front. So I'd have 2 times negative 4, which is negative 8. I'm going to subtract 1. I get x to the negative 5. And then I've got negative 2 times 4, which is negative 8 again. I'm going to erase my plus sign. Negative 8. I'm going to subtract 1. I get x to the negative 1. And then the derivative of the constant is 0. I'm going to do one line of cleaning this up. So I have negative 8. This negative exponent has to come back downstairs, so to the fifth, minus 8 over x to the first. In f here, we're going to make our radicals back into exponents. Remember, the root piece goes at the bottom of the exponent, just like a root is at the bottom of the tree. So we've got x to the 4 divided by, and then there's a 2 out there. If there's nothing there, there's always a 2. So x to the 4 halves minus x to the 7 thirds plus x to the 3 fifths. All right, I could probably reduce that 4 halves to 2. That would make more sense. The other ones I would just leave the way they are. All right, now let's take that derivative. Remember, you need to indicate that you are taking the derivative, so that you need to use that notation properly. So I'm going to bring the 2 in front, so I get 2x, subtract 1 to the first, minus, bring the 7 thirds in front, so you get 7 thirds x. I'm going to subtract 1, but it's going to look like a 3 over 3. So 7 thirds minus 3 thirds is 4 thirds. Plus, bring 3 fifths in front, so 3 fifths x. I'm going to subtract 1, but it's going to look like 5 fifths to the negative 2 thirds power. The only thing I would probably change is maybe bring this variable downstairs because the exponent's negative. So 2x minus 7 thirds x to the 4 thirds plus 3 over 5x to the 2 thirds. Typically, if it isn't like a square root, they will leave these improper fractions rather than putting them back into roots. All right, in G, we're going to do some cleaning up before we try it here. So I'm first of all going to change all the radicals into improper fraction exponents. So, or fractional exponents, not improper fractions. So I get x to the 3/4 minus 2x to the 3 halves, because there's nothing out there, so that's got to be a 2, plus 4x minus 1. Now I need to distribute in that x. So remember, the exponent on this is 1. In order for me to distribute it in, especially to these first two, I would need a common denominator. So the first one, it's going to be x to the 4 over 4, which means I am adding 4 over 4 plus 3 over 4 to get my new exponent, which would be x to the 7 fourths. This to multiply by the second one, I would need it to be x to the 2 halves, so I have a common denominator. And then I'm going to add those exponents together, because when you multiply, you add the exponents. So I have the minus 2x to the 5 halves power. And then x times x would be 4x squared, and x times negative 1 would be negative x. I'm going to go ahead now and take the derivative using my derivative notation. Bring the 7 fourths to the front. So 7 fourths x, I'm subtracting 1. So that would give me negative, or would be minus 4 fourths, which would be 3 fourths. And then I'm going to bring this guy in front. So I've got negative 2 times 5 halves x. I'm going to subtract 2 halves, which is 1, to the 3 halves power. Plus, I'm going to bring the 2 in front. So 2 times 4 is 8. X. I'm subtracting 1 from the exponent, so I get a 1. I'm going to bring this 1 in front that's there, it's invisible. So negative 1, x. I'm going to subtract 1, I get x to the 0. I wrote way too big because I wrote into h, didn't I? I'm going to simplify it a bit. So we've got 7/4 x to the 3/4. Nothing I can do with that. Here, my 2's can cancel. So I get minus 5x to the 3/2 power plus 8x. The x to the 0 is just 1. So I'd have negative 1 times 1, which is negative 1. Probably I would not do anything else with it from that point.